In this video, we're going to talk a little bit more about how strings work in Java. So we have two lines of code here. String s1 equals new string hello. What that does is when we call new, it finds a place in memory, in this case right here, that's free. It puts the word hello in it, and then it creates a variable called s1, and inside that variable s1 it puts the address of where it put that string hello in memory. So 57395 in this case. We have a new variable here called s2, and we also have that equal to new string hello. So that does exactly the same thing. So all objects in Java are pointers, and strings are objects. So that's why we can't use the double equals operator to compare two strings in Java. If we say s1 equals s2, what happens is it looks in s1, and it compares the contents of s1, which is this address, to the contents of s2, which is this address. These two addresses are different, so it returns false. This is almost never what we want, right? Usually if both of the strings are hello, we would like s1 equals s2 to be true because they're both hello. So the way that we get this is by using the equals method in the string class rather than the equals operator. The equals method follows both of the pointers and compares the strings at those memory locations character by character to determine whether or not they're equal. So that's generally what we want in this case. The next thing we're going to talk about with relation to strings is that strings are immutable. Immutable means that they cannot be changed. So here we have again string s1 equals new string hello, so the same thing as before, but now we have this new line s1 equals s1.2 uppercase. So you might think that what this does is goes to this string right over here and converts it all to uppercase. But that's not what happens. Because strings are immutable, I can't change this string. Once I've set it, it's set. So instead what happens is it finds a new open space in memory, let's say right here, and it looks at what the old string is and puts the uppercase version of that at this new memory location. So it does that, and then what happens is it updates the s1 variable to point at this new memory location by changing the address. So now s1 is 57399 to point at this new string. This old string, the lowercase version of hello, is still in memory, but because there's no variable pointing at it anymore, we can't access it. You can only access things in memory if you have a variable that's pointing to that memory location. So what will happen eventually is there's a thing in Java called the garbage collector that runs periodically, and it looks for basically orphaned memory locations where there are no variables pointing to them, and it will free up that memory to make it usable by other programs. Okay, so strings are immutable. Why might strings be immutable in Java? What advantages do we get from that? Well, there are several, but one of them is the ability to intern strings. So this example here is very similar to the first one, except in the first one we're calling new to create the new strings, and in this one we're just assigning them to a string literal. So here we have string s1 equals hello. So that does kind of what it did before. We put hello in an open variable memory location, and we point the variable at that memory address. But here when we get to string s2 equals hello, it says, well, I already have that string literal in memory. So I'm just going to point s2 at that memory location since I already have that there. Well, that's fine, except what happens if again I called s1 equals s1.2 uppercase? If strings were mutable, it would go in and just convert this string right here to uppercase. Well, that would be bad because s2 is pointing at that also, and we didn't want to convert it to uppercase, so that would be a problem. But because strings are immutable, if we call s1.2 uppercase, what will happen is it'll go and find an open memory location, put the uppercase version there, and then update the s1 pointer to point at that memory location. Interning strings is more efficient memory-wise because if we have a lot of strings that are equal to the same literal, we're not wasting memory storing